So it's the last day, Friday at 9 o'clock, and you're all here. You should be very, very proud of yourselves. Anyway, my name is Wade Wegner. I'm a technical evangelist with Microsoft, specifically focused on Windows Azure. And today I'm going to talk about how to leverage cloud storage within Windows Azure with Windows 8 applications. I think my primary goal in this talk is not necessarily to have you leave here as experts with respects to Windows Azure storage and SQL Azure, but I really want you to leave here with some ideas of how you might leverage these services within your applications. And so in order to do that, I'm going to first kind of walk through the various cloud storage offerings that we provide, both through Windows Live as well as Windows Azure. And then I'm going to go through kind of a detailed discussion of what is available in Windows Azure, specifically with Windows Azure Storage and the storage service, and then the SQL Azure database. And then present some ideas and some best practices that you should consider when leveraging these storage services. So again, my ultimate goal here is for you guys to feel a little bit more comfortable and such that at some point in the future when you're building a great Windows 8 application and you say, hey, I need to store some data, or I need to load data, or I need to do something, you have some good ideas as to what to use and when to use it, and feel empowered to move forward. So one of the things that I had thought about with this talk is kind of, well, why does anyone care about storage and data and so forth? And I think fundamentally applications use data, and without data, applications are pretty boring. There's not a whole lot to it. And when your applications are using data, typically you need a place to store that data. And when it comes to data storage, cloud computing really can be beneficial. I mean, you can really tap into something that is far larger than the set of resources that you have locally on the device. And so here is, kind of a prototypical application that I might build. But you can see it's an app. It's got no data. It's got no images. It's got no text. It's got nothing. It's boring. It has no use or function. And it's the data that makes it rich. And so you can see how with just a little bit of a change, now you get something that's a little bit more compelling. So Margie's Travel, you saw John Shuchuk talk about this in the Day 2 keynote, and how, in this context, he was talking about how identity can be that thing that bridges you to rich data up in the cloud. And so this application is made interesting and is made useful through the data that it presents. Everything from images that can come up from Bing, or the Wolfram Alpha data that's sharing some data about Maui, Hawaii, and some of the various places, or even the weather data. And so all of this data comes from the cloud. You can interact with it, you can store it, and so forth. And it's the data and the use of the data and the storage of the data that makes the application useful. And so kind of asking, and this you're probably all familiar with this, but it's worth just touching on real quick is, why do we need this data? And I think really what the data does is it enriches the application. You could have a travel app that did nothing but present a list of your upcoming trips and your past trips and so forth. But it's nice to have a lot of that surrounding data as well. What does the forecast look like? Where were some of the places that I could go to eat and so forth? And so being able to tap into other pieces of data is something that's really useful. And data, especially in the form of images and videos and so forth, can really make your applications more appealing as well. And I think when we start thinking about building applications and tapping into the large market that's going to be there for these apps, the more that you can do to differentiate your application from others, the more appealing and compelling they may be for someone to download, to purchase, and so forth. And so this is why we want to use data and why we would want to store data. Now, why cloud storage? I think probably the top couple of reasons here is, first, the elasticity that it brings you. I mean, cloud, one of the values of it is with like, for instance, Windows Azure is you can tap into a storage system that is far larger than you'd have available to you locally on a device, or probably even in your own data center or set of servers. And as part of that as well, you have the ability to scale, so that you can actually have a storage system that can scale to a lot of users using that data. So elasticity and scale are two of the most common pieces. Another is cost model. Especially with Windows Azure, the cost is such that you only pay for what you use. So if no one's using your data and you're not storing any data up in the cloud, you're not paying for it. So just dependent on how much data you put out there and how much it's used, that's going to define what the cost is for the storage. Another thing about cloud storage is, in many cases, you're going to be running services that your users are going to call into. And it's beneficial to have those services and your storage and your data as close as possible together. So that, let's say your service is making a call to retrieve some data, you don't want that service to have to traverse and do a lot of network hops to get to it. So having that data out in the cloud as well ends up minimizing the data near scenarios where your application needs to talk to that data and minimizes the latency that you might have over network and so forth. And then finally, cloud storage, again, just gives you that opportunity to personalize those applications that you're building. Now, there's a lot of different options here, and I'm going to talk a little bit about some of them, but at the very least, I'm going to talk about these three. The first is Windows Live SkyDrive, and you've probably heard a lot about it at this conference. Certainly, it's a very compelling service and something that we should take a look at. There's Windows Azure Storage, which we'll go into a lot more depth in this talk, and then also SQL Azure Data, database, which we'll talk about in great depth in this talk as well. Now, with SkyDrive, I'm only going to talk a little bit about it because there are dedicated sessions here regarding SkyDrive. But a couple of ways that I think about it to frame up SkyDrive is thinking of it as simple storage and simple sharing. I mean, it really is a compelling scenario where you have these needs to share files and documents and photos and so forth, and tap into Live ID and that live ecosystem. Also collaboration. There's some great, I don't know if you've ever put a document up in SkyDrive and then opened it up and done some sort of collaboration with another user, but it's really compelling. And tapping into that for your applications can be really a really great differentiator. Now, there is a dedicated talk on this. In fact, there's actually 2 talks, and I'll list the other talk in a moment as well. But you should really consider going to these talks, because at those talks, they're going to focus on the core differentiation for SkyDrive, how to use it, what's compelling, so forth. But I do want to at least paint it because it is an option here for you. Now, Windows Azure, at a high level, is a persistent and durable storage system that you can use for your data. You can store kind of blob data, like files and images and so forth. You can also store structured data. So it's not necessarily relational data, but data that still has a schema, data that has some sort of a way of defining itself. It could be very, very simple definition, maybe just usernames and so forth, or it can be a little bit more complex. But there are going to be those scenarios where you want to have structured data, and so that's part of the table service that we'll go into. And one other thing to note is that it also has a way of doing asynchronous messaging, and that's through queues. So there's a queue service that you can tap into where you can do simple in-queue and de-queue operations so that you can offload some sorts of work to different services running elsewhere. By default, the Windows Azure is highly scalable. So this storage service itself runs within Windows Azure, and it scales across many instances and can scale your data so that it can handle a lot of users. And then the last thing that's really important is to know that it is all REST-based. So all the communication, and I'll reinforce this with some examples later on, but all the communication is done through REST. So not only does this, I think, make it compelling for a Windows 8 application, but if you're building this application across many different devices that can still talk HTTP, you can also interact with Windows Azure Storage. So it gives you a nice interoperable story as well. Now, SQL Azure Database is our relational database service. I'm going to make the guess that most of you know what SQL Server is and a relational database management system, and why these things are compelling. The ability to have data that you can aggregate or join together, perform some of these very rich things on. This is what SQL Azure does. But what's compelling about SQL Azure is that it's a managed service. So unlike SQL Server, where you'll have to set up your environment, create your database, manage the database, and so forth, which, there's definitely good use cases for that when you want to use it on premises. But SQL Azure is a managed service, so you just focus on the schema and the way of defining your data and how you interact with that data, and then you let SQL Azure run that database for you. You let it scale it for you, and so forth. So it's a very compelling offering, and I'll get into some more details about that soon. So basically, kind of queuing up the question, well, are there 3 different ways to do this? And when would I want to use what? And what are some of the different values of each? So I tried to create a little bit of I am sure over time I'm going to continue refining this, especially as I start looking at what's going on with Windows Live SkyDrive and such. But here's an attempt at least to call out some, I think, of the unique capabilities of each of these areas. So, Windows Live SkyDrive, and again, the sessions focused on SkyDrive, I think will do it far better justice than I will here. But, these are areas where you're using Windows and you're using Live ID, and you want some personal file storage, and you're synchronizing assets and documents and files, and it's free. And so those are some compelling reasons for that. Windows Azure Storage. Well, we'll talk about it a little bit more, but it integrates directly with our content delivery network so that you can get your data closer to the users that are using it. The fault tolerance, essentially every piece of data that you store in there is replicated at least 3 times so that even if we have hardware failure within the storage service, your data stays preserved and is durable. Again, we've got structured and non-structured data that you can use, as well as queues so that you can do some asynchronous messaging. We just announced, and this is pretty exciting, on Wednesday, that we've enabled geo-replication of your data so that your data doesn't just sit in one data center, but you can opt into having that data replicate to another data center so that in those scenarios where there is some kind of disaster and you need to recover from it, your data exists somewhere else, somewhere physically different. Windows Azure Storage is great for those near compute scenarios where you've got services and applications also running in the cloud so that your data and applications live close together. And it's got both REST APIs, and for those of you that do .NET development, we have a full set of .NET APIs for it as well. So a lot of great things, and we'll go into this in more detail soon. SQL Azure Database, again, relational database, and there's a lot of additional services available through SQL Azure. We've got a reporting service that lets you do reporting on top of your data. There's a data synchronization service that allows you to synchronize your data across databases and across data centers. There's backup restore, export import, and so forth and so on. So these are some of the different capabilities for each. And we'll talk about them more. Again, here are the 2 SkyDrive sessions. There's also a developer's guide to the SkyDrive API talk by Steve. Both of these are today, so if these are things you're interested in, definitely encourage you to see them. So jumping into Windows Azure Storage. So there's 3 primary data constructs to be aware of within Windows Azure Storage. We've got blobs, tables, and queues. Tables are structured data designed to massively scale out. Essentially, you define a partitioning scheme, and then as there's more and more activity, the table storage service is able to scale out your data based on that partition key. And so by defining that partition key up front, you essentially enable the storage service to scale that data out for you. It's also, you interact with it via OData. So if you're familiar with OData, it's a very, very compelling way of calling out and using link-like syntax in order to get that data. Windows Azure Blobs, big files, REST-based, et cetera, and then queues give you that asynchronous messaging capability. Now, at the top, you'll have what's called your storage account. And that storage account, you can actually store up to 100 terabytes of data in each storage account. And nothing is preventing you from having multiple storage accounts. So if you need to go beyond 100 terabytes, you certainly can. And again, since you're only paying for what you use, there's really no reason not to have more if you're not completely filling those out. Within each, you have, within blobs, you'll have a concept of a container, and you can think of that as a way to organize data. And then tables have entities in it, and queues have messages. And again, just to reinforce the fact that this is all REST-based, here are the URIs that you'll end up having. Once you define your storage account, you'll get a storage account name, and essentially you'll address all of these things via HTTP or HTTPS at your account.blobtableorqueue.windows.net or .core.windows.net. And so then all of these interactions end up becoming REST-based using the API. Blobs, essentially there's a lot of characteristics with it. Again, I don't want to get you guys lost in the details here, but there's several things here that I think are pretty useful. One is associating metadata with blobs. Because you think about building an application, one thing you might want to do is minimize the number of writes that you have to do. You don't always want to have to store an image and then write a whole bunch of data somewhere else and have multiple transactions, and you're doing a lot of different HTTP requests in order to do it. So blobs have the ability to attach metadata. So hey, let's say you want to store something up there and attach some text that maybe it's a description of an image, maybe it's a lat long for a geolocation, et cetera. You can use that metadata and attach it to the blob so that you essentially are just pushing that blob up once, but it has all the data that you want stored with that blob. You can have public containers so that you can just have public read-only data. So if you want to serve it up on websites and so forth, everything can be publicly addressable. You also can have private containers that you need to interact with via a signed request header. So basically, it's a way of authenticating to the service to get to private data that you might want to keep private and not make it publicly available. And you can also grant short-lived permissions to private data through something called a shared access signature. And I'll get into that a little bit more with a diagram where it's a little bit easier to understand. Now, there's really two different types of blobs. There's block blobs and page blobs. Block blobs is probably the most common. Essentially, it lets you store up to 200 gigabytes per blob, and it's designed for streaming workloads. So for the most cases, like you're streaming images or videos and so forth, and you want to best get that data delivered to your end user, a block blob makes a lot of sense. Because you can let people stream that so that they're not necessarily having to wait for the entire blob or the entire file to be downloaded before they can start interacting with it. So for instance, here's a case of we want to upload a block file. One of the things that's nice is with the block blobs, you can break these things up into chunks and upload them asynchronously. So that essentially you're not just limiting yourself. You can really chunk this stuff up and effectively get very large files up much faster. So for instance, I might have this chunked up into some blocks and start uploading block 2 and block 4. And at some point, I'm going to also upload block 3. And hey, then I'm going to try to get block 1 up there. And oops, something happened to it. So I'll try again. So there's a retry on it. And so essentially, you basically can push these blocks up asynchronously and on their own, and then when you're ready, go ahead and commit them. So it's very nice for getting this data up in large files available to your users, and at the same time, it's a very, very nice way of giving them the ability to stream that data down. And again, it's all HTTP based, so it's essentially going to be the put verb, and you're going to go ahead and put that block blob up there. And notice too, by the way, you see that authorization header. So this is an example of how you would do the authentication to the service. You attach this authorization attribute, specify your account, and you'll see that hash. That's a base64 encoded string that's been created by a storage account name and a storage account key. So it's a way of signing the request so that you can get access to those resources. Now, page blobs are really nice at doing random writes and random reads. So you can think about cases where you may put up a bunch of data, but then you need to make an update to it, and you don't want to have to re-upload that entire file. You could actually go to different areas within that file and essentially rewrite or update those areas on their own. So for instance, let's take a look at a file. So we upload a 5K file up. We do a put page. And later on, we decide, there's some data in there, and I know where that data is, so I can seek directly to the appropriate bytes. And I'm going to clear out a certain section of it. So, from basically starting at 1K to 3K, I'm going to go ahead and clear that out. And maybe I'm going to do some updates and override some other stuff here, and maybe I'll truncate it later. So it's really nice at letting you target the individual bytes within your blob so that you don't have to necessarily upload the entire file again. So this can be very useful for when you have very large files. One of the other things that it does is I think we're in beta still, maybe it's CTP. We have a concept of drives as well in Windows Azure Storage, where essentially you can create what looks like to the file system an NTFS partition. And the page blobs make this possible because if you think about interacting with a drive that's attached to the storage service, you want to be able to read and write to the various bytes within the blobs that exist in storage rather than having to upload and redo that entire blob each time. So page blobs are very good at that way of reading, writing to individual bytes. And here's going to be the request header that you have when interacting with it. So again, what's nice about this, and I'm going to keep showing this just to reinforce the fact that interacting with this is all done via HTTP. Now, one thing that's really compelling about the Windows Azure Storage Service is the fact that it's integrated directly with the Content Delivery Network. So essentially, you can create a container within Windows Azure Storage and attach it to the CDN. And by doing that, now you say, hey, my storage account may exist in a data center in North America, but I have users in Australia, users in Asia, and so forth, and I don't want them to always have to go to North Central US in order to grab these images. And so by leveraging the CDN, you can cache those images and have those images cached at up to, we have 24 different nodes worldwide, so that those users don't have to traverse all the way back to the physical data center. One thing that's also nice and is in CTP now is if you've got videos, the CDN is also supports smooth streaming so that you can actually have a really nice experience with putting videos up at the edge and then giving people the ability to stream it smoothly. So here's kind of a way to think about this. So basically, here's my data center. Here's my user down in Australia. So Mr. Nick Harris is sitting down in Australia, and he wants to access a resource. Without the CDN, I'm going to have to go all the way up to the North America and come all the way back down. And gosh, doing that over and over again, that's going to create a pretty bad experience. So instead, what's going to happen is I'm going to try to go first by using the CDN to the local node that's actually in Australia. Now, the very first time this occurs, the image has not been loaded into cache. So the CDN will go back all the way to the data center and grab that image. And once it's grabbed it, then it can return the image to Nick. So Nick, unfortunately, because he came to the CDN first, pays a little bit extra cost for getting that image. However, once that's done and it's been cached, every single request that any other user, not just Nick, has when they load up that image from Australia, that image has already been cached. So it's much, much faster. In fact, take a look at the attempts to route this. So on the left, you'll see a trace route going directly to the storage account. And on the right, you're going to see the trace route to the CDN. So much, much faster, a lot less network hops and so forth. So CDN is a great thing to take advantage of when building your apps, and it's a great thing to think about for your Windows 8 apps as well. So tables we've talked a little bit about, but tables are that flexible schema, that structured data that you can store in Windows Azure. But it's also massively scalable through the partitioning scheme that you define. And it is also durable. Everything on the storage service is stored and replicated 3 times so that even if we have a hardware failure, you still have access to that. And there is no limit on the number of rows and amount of data that you put into each one of your tables. It's a very simple REST API. It uses the OData protocol. So essentially you can you can do link statements against it. And just like with the blobs, there's the concept of a shared key that you'll use to sign the requests. There's also a shared key light authentication mode which you can use. It's not necessarily recommended. The shared key approach is more secure and useful. So definitely, I would encourage you to use the shared keys. Also with tables, if you have a table that has millions and millions of rows and you want to do a select from it, you don't really want to get back millions of rows. But you may want to do paging or give people the ability to go through lists and so forth. And so we have the concept of a continuation token. So when you do a get off the table and you say, bring me down 20 rows, what it's going to also bring you is a continuation token so that when you want to get the next 20 rows, you can present the continuation token and the storage service knows then what the next 20 rows are to bring down to you. So you can do things like paging and so forth through tables. Now, there is a primary key system. Essentially, it's a combination of a partition key and a row key that you define. Now, the partition key, again, is going to be that piece of data that the storage service uses in order to figure out how to scale your data and essentially how to start slicing it up and distributing it across our servers. So that's one element of the primary key. The other is the row key. And so you can use a combination of these things to define what your primary key structure is, which essentially defines the order of the data, and then interact with that data as such. There's also a timestamp system property as well. So when you do various operations against it, there will be a timestamp that's placed there. So here's an example of doing a post to create a table. So you can see there's going to be a request header portion of it, which is not really included here. But then there's also the body. And you can see then there's an XML schema used to define how it goes about interacting with the storage service. And in this case, we're going to create a table called myTable. So again, all HTTP based. Now, the last thing we'll talk about for the Windows Azure storage system is the method of doing asynchronous messaging through Windows Azure. And we do that through queues. And essentially what a Queues does is it gives you a durable, reliable place to put some data. It's not a lot of data. It's 60, well, it used to be, I think it used to just be until a couple of days ago, 16 kilobytes. Now it's 64 kilobytes. And, but basically you just put some data there that could be read by another process. So imagine that I've got a website running in a Windows Azure web role, and I want to get some sort of instruction from a user. Rather than making that user wait, or rather than running that operation in the web role, what I can do is I can store that information into a queue, and then I can have a worker role running in the back that will extract that data. Similarly, for like a Windows 8 application, you could have a service running in Windows Azure that from your Windows 8 application, you call that service, hand it a message, and then the service places it in the queue. So there's a number of different ways to use it, and using queues to kind of do this asynchronous processing is quite useful. So yes, like I said, so 64K message size limit. There is an expiry on the queue, so after 7 days it will disappear. There is also the concept of some sort of control over it, whereby when you place an item in the queue, when you do that dequeue operation and essentially grab it, it will remove it from the queue. So that another, let's say you've got multiple worker roles running in the background. You don't want two different services grabbing that same message at the same time. So there is some consistency there. However, you need to make sure that your operations are idempotent such that if something happens during the processing of that message and it fails, eventually that dequeue operation will time out and the message will go back into the queue. So another service will pick that item up and start processing it again. So make sure that you build your system such that they are idempotent and they recognize the fact that they can grab a message from the queue at least once. So we guarantee that you'll always get the message at least once. But depending on how you write your application and if there's maybe some application logic issues or maybe there's hardware failure, it is possible that that message could get run more than once. And here's an example of how you would do a put message. So you can see the header at the top doing the post, and then in the body we define the queue message and then the message text. Now one thing that we made available fairly recently, maybe within the last month, is analytics on top of storage. And this is really nice because prior to it, it was a little bit difficult to get some insight into the various metrics surrounding how people were interacting with data that you had in storage. You didn't have rich logging and so forth. And so with the storage analytics now, we have the ability to do both logging and getting metrics on top of that data. So you can take a look at the different requests and trace them out. You can take a look at usage trends, diagnose issues. We basically provide all that raw data to you, and then you can extract the useful information from it. Now, it's not turned on by default, so you do have to enable it. But once it's enabled, it'll actually start collecting and gathering this information and storing it in special containers and tables within your storage account. So you have a very easy way to get to it. You just basically perform the same operations against the storage service to get your logs and to get your metrics. One thing I will note is that in the storage client API that's been written for .NET, it has not yet been updated for storage analytics. So Steve Marks, who's a product manager on the Windows Azure team, actually wrote a great set of extensions to the storage client library where you can pull that in, and he's got a really nice managed API that you can use. Of course, you could still go directly against the REST service as well. Now, on Wednesday, we announced all these new features in Windows Azure Storage. And I mentioned things like GeoRep and so forth. We also have like table upserts and so forth. Rather than getting in and repeating a lot of the information that Brad already discussed on Wednesday, I just want to call out the fact that you should take a look if you're interested in this at Brad's talk. This was again Friday at 5 o'clock, and he really kind of gave an under-the-hoods look, since Brad Calder is the GM for the Windows Azure Storage Service. So he gave some really useful kind of under-the-covers look of the storage service, but then he also spent a lot of time talking about these new capabilities. I think this might be the last thing I have for Windows Azure Storage, but it's an important thing. When you're interacting with the REST APIs, if you're not using the storage client library and you're going directly against the APIs yourself, one thing you have to note is you need to put in the request header a version number, because every time we update the service, we'll also give the new capabilities this version tag so that basically, we don't want to break you. So let's say we have a certain method of operating against, I don't know, an insert in table storage, and we decide, hey, we can do this better. Let's create a new way to do it. Well, we don't want to break everyone that's doing it the existing way. So you always version your requests with this attribute. So you want to make sure, like, if you guys go off and start looking at some older examples from 2 months ago, but then try to interact with some of the new storage API capabilities that were on the last slide, well, they wouldn't work unless you had this new MS version attribute in the request header. So just be aware of that if you start going directly against the REST APIs, that this is something you'll need to take into consideration. So real quick summary of the Windows Azure storage is, we've got blobs, tables of queues. Each of them have, I think, different and unique and compelling use cases. And the Windows Azure storage team has a great and fantastic blog. Some of the more detailed blog posts I've seen, maybe not quite as detailed as some of the Build Windows blog posts that are pretty rich and compelling, but still lots of useful information in there. All right, so with that, we're going to kind of pivot and talk a little bit about SQL Azure. So SQL Azure Database. Everything you know of SQL Azure, for the most part, I mean, it's nothing's changed. SQL Azure is based on SQL Server, but it runs as a managed service. So it's very, very easy to provision and create databases in it. There's a provisioning model. There's even a set of APIs you can use to create new database servers, and within them, then you can just perform, create database via T-SQL and create whatever database you need. Highly available, so very much like the storage system with Windows Azure, this data is also replicated across multiple servers in the backend. So even if something fails, that data still exists somewhere else. Now, one thing I'll note is by default, it doesn't prevent you from doing bad things to your data. So if you decide to delete a table, hey, we're gonna replicate that delete operation across all the other images as well. So it doesn't prevent you from doing something to your data. That's why you need to back it up. But if there is hardware failure or something like that, we can recover from it, given the fact that it exists in multiple locations. It is an on-demand service, so you can scale it up. You can scale it as you need to. There are SLAs around it. There's the concept of multi-tenancy, where you can have multiple databases within the database server, and it exists in all 6 of our data centers. Oh, and I think on the last slide, or in that last box, what's worth pointing out is you're not having to learn new things as well. T-SQL, the tools like SSMS, SQL Studio Management, SQL Server Management Studio, all of these things still apply and are useful. So, it's very quick and easy to get started with SQL Azure. I alluded to some of this stuff as well. So here's kind of a little diagram detailing the fact that we keep multiple replicas of this data across different disks. It's based on SQL Server 2008 and so forth, and you can find it throughout all 6 data centers. Now the goal, and the teams are working really hard on this. The goal is symmetry between SQL Server and SQL Azure, and it is pretty darn close. It's rare that you'll find something that is significantly different, from both the T-SQL features to the tools to how you connect to it and the frameworks that interact with it. Some of the differences that might call out is within SQL Azure, since we are synchronizing this data and replicating it to multiple machines replicas, it does require a clustered index on each table. So a lot of people have gone down some paths where in order to scale their data out, they've removed certain things like certain indexes and so forth, or they want to be able to write things fast. So just note that if you try to move a table up and it doesn't have a clustered index, you're going to have to create one. You also don't, since it is a multi-tenant service as well, you also don't have access to the core system tables as well. So there are some differences in terms of how you use some user-defined functions and so forth, but not very many differences. And then there are some features such as like encryption, the service broker, if you want to create CLR objects that can interact with your database, those things aren't supported in SQL Azure. Now, in terms of how you connect to it, this is what's probably the coolest part of it is there's really no difference. SQL Azure also uses TDS to communicate between the app that you write and the service. Essentially, SQL Azure creates a TDS endpoint that you communicate to over over the internet. So it doesn't change your protocol. So if you're using ADO.NET today and you've got, let's say you're building a web app or you're building a local app or whatever it might be, you're going to have a connection string in which you refer to like a database server and a database name. All that changes is instead of pointing to a local server name, you're going to point to a URI which represents your database out on SQL Azure. And so you're communicating over the web, over the internet, to that database through that connection. In that case, all the libraries and so forth that you need are consistent. If you're going to deploy some stuff to Windows Azure to communicate to it, you just make sure that those client libraries exist. But again, very, very few changes. In fact, in most cases, you can do a lot of local development against SQL Express, deploy your database out, and the only change you'll make in your application is just changing that database server name in the connection string, and your username password potentially. Deployments, there's a number of different ways to do it. Of course, you can just use T-SQL scripts and execute them against your database. That's certainly kind of the brute force way. There's also support for DAC packs, so the data tier applications, where basically a DAC pack defines a unit of deployment, which includes your schema, your database objects, your SQL objects, along with your data. You create that DAC pack, and then you can go ahead and deploy that DAC pack. So there's a number of different ways that you can go about deploying these databases. Now, the security model is consistent to SQL Azure, so you do get a SQL login. So there'll be, when you create the database, when you create the database server, you do need to define a administrative account, which essentially becomes a SQL login. And you'll use that login to connect up to and communicate with your various objects. And you can create other users as well, so you can create additional SQL logins. So it's basically a username password approach to interacting with SQL Azure. So that's SQL Azure quickly. And now what I want to do is pivot a little bit around, all right, so we've got these different things, and hopefully you all feel a little bit more comfortable and familiar with it, with Windows Azure Storage and with SQL Azure. So we'll talk a little bit about some patterns and best practices for interacting with them. Now, the first thing that I want to address is secrets. So we talked about Windows Azure, how you've got a storage name and a storage key. And SQL Azure, since it supports the consistent SQL login model, there's going to be a username and password. So what do you do? Like when you're building a Windows 8 application, or really any kind of device application, do you put these secrets down on the device? Do you put them in your application? Probably not, because regardless, people are always going to try to get access to your secrets. And it's best just not to put them down in the application. And so, because once you do and someone gets access to these resources, well, then those secrets are not secret any longer. And so there's a pattern that you can use that is very simple, and I'm sure this won't be a surprise to any of you, but it's definitely something that you should consider. Like here we've got an application or a device that's going to be interacting with data. Well, instead of putting the secrets right on the device, you put the secrets in a service that's running up in Windows Azure, so in your web role. And so then the device will talk to that service, and certainly you can do some form of authentication to that service. You could use a traditional membership store. You could basically the ASP.NET membership provider model, and you could use tables or SQL for that. You could use an existing identity provider like Facebook or Live to authenticate to it, or, and this would be my preference, use the access control service within Windows Azure. But regardless of that operation, your data secrets stay up in your service, so no one has access to them. So at that point, then, your web role is able to actually proxy those requests to the storage services for you. So, and there's variants and variations of this that we will talk about, but this is the basic idea. Now, when looking at the different methods and options for connecting to these storage services, I find it useful to point this out. With Windows Azure Storage, from most devices, since you interact with it via HTTP, you can talk directly to it. So if you did put the key on a device, which again I do not recommend, but you can talk directly from your application to Windows Azure Storage over HTTP. SQL Azure is a little bit different since it's TDS, and unless the client or the device is able to talk TDS and understand that protocol, they're most likely not going to be able to connect. Now, in something like Windows and Windows 8, that shouldn't be a problem, but let's say you want your application to also span across devices. If you go to the phone, most phones aren't going to be able to talk TDS directly to SQL Azure. So in most cases with SQL Azure, you'll end up proxying these requests through a service. And so essentially what I'm getting at is the best and probably most consistent model and way to do this is having services that you use to proxy. The one caveat to this is with private blobs and the ability to use a shared access signature. Because sometimes you want to upload data or give access to your users to data and not make them go through a proxy. Because a proxy can slow down the operation. And sometimes you just want to give them access directly to the resource. And so what a shared access signature allows you to do is give them a temporary access to a secured resource. So what you'll end up doing is the user or the device or the application would call to your service. Your service has those storage secrets. So what it can do is create a shared access signature using those secrets and essentially create a short-lived policy that grants access to a secured resource. So they'll send that shared access signature back down to the client. And that client will get that back in the response and then can use that information to then perform an operation to Windows Azure storage. So this way, your resources stay secure, this user has temporary access to it, and then they can perform an operation, they can get data back, and so forth. Like a good example of this that someone brought up is, I may want to create a website or an application that shares video, but I don't want people to be able to get to this stuff without authenticating somehow. Right? And maybe I want them to log in and I want to serve up some ads before they can watch this video or whatever the use case might be. I don't want anyone to just be able to go directly against the resource in a read-only public fashion. And so by using the shared access signature, you could still give them direct access to the resource so that they can benefit from smooth streaming, they can benefit from progressive downloads, all those things, but at the same time make sure that these things stay secure. So SQL Azure, just to really reinforce and beat this into you, does a great, using services is a great way to proxy those requests to SQL Azure. And guess what? If you're interested in going into this in a little bit more depth, yesterday I gave a talk very specific to devices. I talked about Windows 8, Windows Phone, iOS, and Android, and went into these patterns in greater detail and showed a lot of examples. Now, what I wanted to do now is I have a demonstration that I'd like to show in basically a Windows 8 application that's going to be communicating to some services that interact with storage. But before I do that, I'm not going to spend as much time on the services, but I wanted to show just in a couple of slides what's driving the services on Windows Azure. So essentially, I've got a REST endpoint that I've built with MVC. And it uses a controller. So you can see here in the controller, I've got a method called just getRandomComplement. And in it, what it's doing is it's using our storage client library and our managed APIs to interact with the storage system. So the storage client library handles all the REST, HTTP communications for us, and it gives us a nice object model, a nice API to use in managed code. And so you can see here I'm getting my data connection string, which has my storage name and key. I'm creating a context for the data service, and then basically I'm doing a link query against it to get a set of complements back, and then I just randomly choose one of those complements and I return it. And when I return it, I'm using a JSON. I'm returning it as JSON. So here's the JSON result, essentially. Basically shows you how we can, and apologies for the formatting. A lot of these, the library is fairly verbose, and I didn't want to shrink the code down too much or no one would be able to read it. But basically, we've got this complement object, and we're just, we're now mapping it to a JSON result that we're going to send back to the client. So this is what's running up in Windows Azure. And so what I'm going to do is show you a extremely complex Windows 8 client that's going to call to it. So switch over here. Looks like to log in. All right. So we're going to create a new project, and just a blank JavaScript-based Windows Metro style application. And in the body, I knew my fingers wouldn't be typing well, so I created some snippets for it. Let's see if this, hopefully it loads the toolbox. We're just going to throw down a couple of HTML snippets for us. I think, I hope. All right, let's just open up one that I've already created. All right, so in here we've got just a couple of very simple things. We've got a text area. So within the body, it's just a text area where we're going to be able to write some stuff. We've got a little bit of CSS. I'm not very good at CSS, but this at least lets us use all the real estate available to us. And then I've also got an audio tag there as well, because I want to play up some audio. Now, in the code behind, what I've done is set it such that through the Windows libraries, I'm able to do a call out to my REST service. So my REST service is at flateris.com. By the way, you should, at some point, maybe I'll pull it up, go to flateris.com. It's a great site. And there's this method called getRandomComplement. So that's that MVC controller and the JSON result parser that you saw. And essentially, it's going to give me back that random complement. Now, within that JSON result, I've got a couple of things. I've got some text that I'm going to bind to our text area. But then I've also got a URL that points to an MP3 file so that I can attach that as source to our audio tag. And then I'm basically just defining that type as audio MP3. So let me go ahead and run this, and we'll see what it does.
Your personal hygiene is above reproach.
So this is a getRandomComplement. I thought that was a nice compliment. Let's run it one more time.
Have you lost weight?
So if you ever need a little pep talk, go to www.flateris.com. The voice of Steve Marks will make you feel better about yourself. Really, though, that's how simple it is from this application. Since we've got a REST service that's proxying the requests for us to our service, we're able to just use the Windows libraries to call out to that service and get that JSON result back, which we parse and then use within our application. So very, very approachable. I challenge anyone to say that this is complex or difficult. Of course, if we wanted to do other things like perform authentications and so forth, we'd have to do a little bit more. You know, we could call into the Windows web broker to manage the interaction to identity providers. We could get back a credential, a token, stuff that into the password vault, and so forth. And if you're interested in those things, there are two talks to take a look at. One is the devices talk that I gave yesterday, where I walked through how this stuff works and how you can use different types of identity with the Windows 8 app and Windows Azure. And then also Vittorio Bertacci, who's a PM on the identity team, gave a very detailed talk yesterday about identity in the cloud and going deeply into some of the new capabilities found within Windows 8 for it. So very approachable, very easy to do. But it really, I think, emphasizes and shows how creating these services that you use for interaction between your application and your data provides a lot of value. So in quick summary, again, I told you in the beginning, one of the things I want you to leave with is just a general idea that when you start working with data when building your Windows 8, or really any kind of application, there's a lot of different opportunities available to you in the cloud, and especially within the Windows Azure Storage Service and SQL Azure. Understanding a little bit about them is going to save you a lot of time, so that when you do start digging a little bit deeper to figure out which one to choose, you know enough about it to go find that data. I don't expect any of you need to leave here remembering everything that we went through, but as long as you remember you heard something about it, you can generally find that information pretty quickly, and then hopefully use that knowledge to choose the right solution. And I do believe that within Windows 8 applications, using Windows Azure for storage and SQL Azure is going to provide some really great opportunities for you for building applications that benefit from data. Some related sessions. Now, this is just emphasizing without good data, this is just not compelling. So add the data, and then it gets a little bit more useful. So here's a bunch of additional sessions to take a look at. There have been some really fantastic Windows Azure sessions, everything from getting started to Vittorio's Identity and Access Management talk. Mr. Nick Harris and Darren Huey gave a talk on delivering notifications to Windows 8 applications using the Windows Push Notification Service. Of course, there was a talk on devices and clouds. And there's two talks today that I think will be great. So building global and highly available services using Windows Azure is going to be given by Mr. Matthew Kerner. And then building scalable web applications with Windows Azure is being given by David Aiken. Social games, so if you're interested in how you can start using, and this is actually a really good one too, so if you're interested in storage, Nathan Totten gave a talk on building social game applications with Windows Azure, and he talked through a number of patterns whereby you can use Windows Azure Storage to manage game state and manage interactions between users that are participating in a role-based game, and some of the benefits, some of the challenges, and so forth that you'd have to be aware of. So that was a great talk. And then, of course, Brad Calder's talk, Inside Windows Azure Storage, is definitely one to take a look at if you're looking for more. And with that, we've got 10 minutes to answer any questions, and I appreciate your attention and you guys showing up. And please, if you have a question, I can't see you very well because of the lights, but we do have microphones in each one of the aisles. So if you have any questions, feel free to walk on up to the microphone.
When you were saying that you could have the shared, I guess it was the shared key or a temporary shared key to go get an image or something like that. So let's say you've logged in and you're getting back just a URL and you want to just data bind. You've got like an image object and you just want to data bind the image source to that URL. Do you get just a straight up URL that you can just do a get on? Do you append something to the query string, or how does that work?
Yeah, so when you get the shared access signature, it's giving you back a URL. And that URL has a bunch of metadata attached to the query string. So you essentially use that URL to then send another request to the storage system. And so using that and with the information that's been added to that URL, you will be able to get short-term access to those resources and to be able to then make any sort of calls or operations back. Now, when you're doing that, you're going to be talking directly to the services, and this is only for blob storage. So the shared access signature is for blobs only. So you'll get back your blob, your blob. So basically your files and images and so forth. When you get that data back, yes, you can load that stuff up directly in your application. Since it's not for tables, it's not really a data binding type scenario. If you want to get data back and it's, since it's secure, that's where you really want to kind of do what I showed in this demonstration, where you use like a REST service and you call to the REST service and it grabs the data from tables and then returns a JSON string that you can parse and do data binding on.
Well, I was thinking like XAML data binding.
So XAML data binding as well, yeah. So you just return the results and then handle it and bind it. But again, you'll want to go through a service for that, because most likely when you're getting this data back, it's going to be data stored in table storage, which does not support shared access signatures.
Yeah, I was just thinking about the blobs. And then for the time that those are available, is that something that...
It's configurable. So you can set, when you create the policy in your service or wherever, you can choose different durations. I forget what the maximum is. I believe I've created a shared access signature that granted access to a resource for a year, but you can certainly do it a lot shorter as well.
Okay, thanks.
Yep.
So you said there is automatic replication of your files when you store something in the blob storage. Do you put a load balancer in front of it so when multiple clients are requesting, you can actually serve all those? Or is it just for backup?
Yeah, no, great question. So when you interact with storage, you will go through a load balancer. And since the storage service runs in Windows Azure, based on a number of different characteristics, like how many transactions are being processed, how long they're taking, all those sorts of things, the storage service can scale out the interactions with the data across many different servers. And so by going through the load balancer, it can fan it out such that it can handle your scale needs through the load balancer.
So the service itself is going to figure out how many files do I have to replicate on multiple nodes to serve this load right now?
Yeah, basically, So for instance, let's say you have tables and you've got a bunch of data stored in tables. It is very possible if there's not a lot of activity or a lot of data and so forth that you're really just interacting with it running in one spot. It's not been partitioned or basically scaled out through the storage service. But then you start getting a whole lot more activity based on the way you've partitioned your data. Then the storage service can say, you know what, it makes a little bit more sense to kind of break this out so that I can start utilizing additional hardware and so forth to handle the requests that are coming in. And so again, you're just going to a consistent endpoint. The load balancer and basically the storage service is able to figure out then how to route those requests and traffic appropriately.
Thank you.
Any other questions?
So when you query table storage and your query is more complex than simply querying by partition key and row key, for example, with a link expression, is there table scanning going on? Is it having to pull a lot of the data from the table into memory and then query within memory?
Yeah, so one thing to point out is the table service is an OData service, but it doesn't support all the OData operations. So for instance, if I constructed an OData kind of link query statement and I put, I think, like order by on it to adjust the order of the return, this table storage service doesn't support that. So that's why it is important to define the right partitioning schema, because your data will be sorted and come back as is. If you want to change that, then you'd be responsible for pulling that data down and then in the client having it in memory, and then you can do additional like link operations on it and so forth to manipulate and massage that data. Of course, if you have a lot of data, you don't want to be pulling it down. So a technique people will do is create different tables that store and sort data differently. And even in cases where you need to maybe aggregate some things, like maybe you've got a whole bunch of transactions about what different users in a game are doing, but you want to do some kind of leaderboarding or something else where you want to have an aggregate of certain types of things. People will write a worker role that will grab this data and perform the aggregation and stick it into another table, so you could call to that table and get different forms of your data. So there's a number of different ways to go about it, not necessarily just through kind of the link statement via OData.
Okay, and then my understanding is that there was a feature, perhaps it's only in CTP at this point, where you would be able to add additional indexes on table storage. Is that correct?
I think this is one of those fun things. I think even back in 2008, we were talking about how we would bring a secondary index to table storage. Still fully intend to do it, but one of the things that's really occupied the team's time has been implementing the geo-replication and some of these other capabilities that are needed. So secondary indexes are not available today, even in CTP, but it's still a priority. It's still on the roadmap, and at some point, hopefully in the near future. Of course, we've been saying this for a few years, but it's still on the list of things to do. So if you've got feedback, there's a great website to go to. I think it's Migrate Windows Azure Idea or something like that, where you can go vote on the features that you want. And the teams do pay attention to that and prioritize the things that get a lot of votes. So.
And then related to the geo-replication, is there any plans to do that for SQL Azure in addition to the Windows Azure storage?
Yeah, I think the teams have talked about that as well. One thought and one approach is to using the SQL Azure Data Sync service, which essentially uses Sync Framework as a part of a managed service to replicate your databases. And so you can essentially define a database in multiple data centers in different geos, use SQL Azure Data Sync, and that data will replicate across. It's not. You could use it as some kind of backup and so forth. There's probably other ways. Like for instance, we just released into CTP the export-import capabilities, where you can actually do an export of your database directly to a Windows Azure blob storage. So that's, in that way you're getting it. You can move it into Windows Azure storage. It could be replicated there and so forth. Yep.
Hi.
Hi.
If we use SQL Azure table-wise and we try to use Access with the OData protocol, how you can make it authentication about the caller?
So your OData service would have the connection string to SQL Azure, right? So that would stay up in Windows Azure, doesn't need to go down to the client, et cetera. One of the things that you can do in the OData service, and I'll point you to a couple of examples in a moment, but essentially is when the request comes in, take a look in the request header to see if there's like a token, right?
Okay.
And like for instance, if you use the access control service, when you log in and authenticate with the access control service, you'll get back that token. When you then make the request against the OData service, you can take that token, put it in your request header, and then send it along as part of the request. Then the OData service can inspect the header, check for the token, and with the token and using something like Windows Identity Foundation can validate that that's a legitimate token and perform whatever checks it needs to do before then going back to SQL Azure. So if the token isn't there or if the token is wrong, then you never go back to SQL Azure. You'll just return a response that says like forbidden.
So you cannot access directly, the OData part of the SQL Azure. You need to wrap up and put it a layer between these two stuff to make that.
To be clear, so like SQL Azure itself doesn't have an OData service, right? But that's for Windows Azure table storage. So there's an OData. That's the service that works with OData. To authenticate there, you could do the same sort of proxying technique where I mentioned that you put the token in the header and you validate it before you make the request to Windows Azure Table Storage. Otherwise, you'd need to use the name and key to sign the request if you're going to go directly to table storage. And that's the piece that I recommended not doing, because then you're putting your secrets right in your application, which is not particularly secure. So I've got 10 seconds left.
The last one. So SQL Azure, it works over TDS, and it requires 1433, the
Yep.
SQL port.
Yep.
And a lot of the organization, like myself, block that port.
Yep.
So do you know of any proven workarounds to work it over internet?
There's some workarounds. I don't know that any of them are as good as finding ways to open up that port, or at least making it a little bit less restrictive. For one thing you could do is get the known IP addresses. We publish these. You can call up, or you can contact Windows Azure support or help desk as well to find out what the IP address block ranges are for our different data centers. You could work with your networking staff to unblock that port for these known IP addresses. That's your best bet. Of course, you could do a lot of cool things, like with the service bus connectivity. You could create a listener on a different port that then proxies your request through the service bus somewhere else, so that it can hit it on 1433. That adds more complexity and things that can go wrong and so forth. So best bet is to find a way to unblock that port.
So is there a web management console that uses that I can use that works over HTTP, or does that work?
Actually, yeah. So if you log into the standard Windows Azure platform portal, there's a tab for SQL. When you go to it and you select your database, first of all, you'll see your database server and all your databases, and you can manage your logins and so forth. You can also select the database, and I think it's either called Manage or Admin, but it'll basically load up the SQL Azure portal, where you can. It's very similar to SSMS, where you can run T-SQL statements, you can create objects, like all those different things that you might want to do to just interact with your data.
Okay.
So, yeah. Thank you guys very much. Really appreciate your attention and coming.